All right, 7.1, number 5. Here's our equation. We're supposed to determine when the particle is moving to the right, to the left, and when it's stopped, and then find the particle's displacement for the given time interval, and find the total distance traveled by the particle. All right, so I'm just going to make a sketch of this. Pretend I don't have access to a calculator, so we'll bring back our Algebra 2 days where we talk about double roots and single roots. So if I wanted to find, just to sketch a graph of this, you could find the t-intercepts or the x-intercepts here. So if I just set this equal to 0 and this equal to 0, cosine is 0 at pi over 2 and 3 pi over 2 when we're going from 0 to 2 pi. So on the unit circle, pi over 2 and 3 pi over 2 is when cosine is 0. Square root, so basically sine of t equals 0. Where is sine equal to 0? So on the unit circle, sine is 0 at 0, and at pi, and at 2 pi again. Okay, so 0, pi, and 2 pi. So making a sketch from 0 to 2 pi. I know it's going to go through the t-axis, or the x-axis, it's t-axis here, at pi over 2 and 3 pi over 2. This is a double root. So if it's double root, that means it bounces off the x-axis or t-axis here. So it's going to bounce off at 0 and at pi and at 2 pi. We just don't know whether it's bouncing off from above or from below. So if I just plugged in maybe pi over 4, and then I'm just going to find out if it's above the axis or below the x-axis. So the sine of pi over 4 is square root of 2 over 2. Squared would be 1/2 times 5 is 5/2 times the cosine of pi over 4, which is square root of 2 over 2. All I really need to know is if it's positive or not, and it is positive. So I'm going to make a sketch. So it's going to bounce off at these 3 points. It's going to go through at the other 2 points. So it's going to kind of look like that. So there's my sketch. This little hump is a little smaller than that one. I think they're supposed to be the same size. Okay, so when is it moving to the right? That's the first thing I asked. And to the left. So it's moving to the right. What are my 2 intervals in which it's moving to the right? Good. So we're moving to the right here, and here you're going to say, right?
Yeah.
So then we're moving to the left here, we're moving left here because it's a negative area, it's going backwards, it's going to the left. Okay, so if we want to know when is it moving to the right and left, we just figure that out. Right is here. Find the particle's displacement for the given time interval. So the displacement in the time interval from 0 to 2 pi, so B is displacement. We would just integrate our velocity pi, and that'll give us our displacement in that time interval. Okay, so displacement considers positive and negative area. So it looks like, if I had drawn it correctly, there's going to be just as much above the x-axis or t-axis as below. So it looks like we might have 0 for our total displacement from 0 to 2 pi. We should probably double check, so we should integrate from 0 to pi over 2, and then from pi over 2 to pi, and if those are the same except opposite, then we're feeling pretty good about the whole displacement in the interval being 0. So let's integrate from 0 to pi over 2, so it's 5 sine squared t cosine t dt from 0 to pi over 2. That looks like a u substitution where u is sine t. Because it's okay to have u squared But if I chose my u as cosine t, that'll get rid of one of my signs, but not both of them. So if this is being squared, that's going to be your u. So du dt equals cosine t, dt equals du over cosine t. So then we have the integral from 0 to pi over 2 of 5u squared cosine t dt, which is du over cosine t, and the cosines do divide off. So it's integral of 5u squared du. Antiderivative of that would be 5/3 u cubed from 0 to pi over 2. So plug our u is sine t, so it's 5/3 sine t cubed from 0 to pi over 2. So the sine of pi over 2 is 1. Cubed is 1 times 5/3 is 5/3 minus sine of 0 is 0, so that makes it easier. So we get 5/3. Okay, so this area is 5/3. So if our intuition is correct, then from pi over 2 to pi should be what? What would we get for an answer from pi over 2 to pi? Negative 5/3, right. So let's verify that that is the case. So we already have the antiderivative, so it's 5/3 sine of t cubed from pi over 2 to pi now. So sine of pi is 0. Sine of pi over 2 is 1, so we do get 0 minus 5/3, we get negative 5/3, as we suspected. Okay, so I'm feeling pretty good about our displacement from 0 to 2 pi being 0. You know, if we wanted to be really clear, we could find that area, and add up all the areas, but based on the symmetry and the fact that they're periodic functions, sine and cosine, I'm comfortable saying that that is 0. Part C, find the total distance traveled by the particle. So the particle moved 5/3 to the right, 5/3 to the left, 5/3 to the left, 5/3 to the right. So it does move. So the total distance would be 5/3 times 4. So it'd be 20/3 units, whatever our unit is. That's our distance from 0 to 2 pi.